Okay, we're going to start talking about adding and subtracting rational expressions. So let's go back again. I like to do this a lot, is go back to the elementary days when we added fractions and how we actually did that. So if we had something like 3/5 plus 4/7. So how do we do that? Well, we got to think of trying to get things, I like to think of it in the same unit, right? We can't really add fifths and sevenths, so we need to get them in the same unit, and to do that we have to find the LCD, which we talked about in the last section. Well, the least common denominator for 5 and 7 is 35, right? And so what we would do is try to find equivalent fractions where 35 is our denominator. Now, back in the day we used to write these vertically, that's how I did it anyway, and I would suggest you do that in this section. So if I want to do this problem, I would write 3/5 plus 4/7. Write your LCD over here, so 35, right, we decided. And so now we could see, well, what do we multiply 3/5 by to get something over 35? We multiply by 7/7, right? So that gives us 21/35. Here we multiply by 5/5. That gives us 20/35. And then, now that they're in the same unit, we have 21/35 and 20/35. We can add them together, and that gives us 41/35. So that's what we're going to do, just with rational expressions rather than fractions that have integers on top and bottom. So let's look at this first one, x/4, and this is a plus. I know it's kind of blurry, but that's a plus sign. All right, plus 5 minus x/4. If you have the same denominator already, you can simply add them together. Add the numerators together. The denominator stays the same, right? It's not like multiplication where you can go straight across. Denominators have to stay the same. So if we take, and then maybe I'll write this vertically. I like to get in that habit. x/4 plus 5 minus x/4. They already have the same denominator. We just need to combine the numerators. So if we have x plus 5 minus x, well, what happens? Well, x minus x, those go away. We just have 5, right? So here we just get 5/4. That would be our answer. The next one, again, we have the same denominator already. This is a subtraction problem. With subtraction, we have to be a little bit careful. Okay, I'm going to write these vertically again. Minus. Now, when you have a subtraction in front of a fraction, the fraction bar is a grouping symbol. And they don't write it this way, but you should, so you don't get confused. Put parentheses around that numerator. That minus sign should get applied to both parts of the numerator. So we really have a minus x minus a negative 5, which is plus 5 over 2x minus 3. So we have minus x plus 5. So 5 minus x plus 5. Well, we can combine the 5's, right? 5 and 5 is 10. And we have the minus x over 2x minus 3. And that would be our answer. So anytime you have a subtraction, don't forget to apply that minus sign to both parts of the numerator that of the fraction you're subtracting. All right, let's look at the next one. Here, this doesn't look like a fraction at all, but we can put it over 1. All right, I'm going to write this vertically, 3x/5. This is addition, so plus 5x/1. Well, here we don't have a common denominator, so we need to find one, right? What do 5 and 1 both go into? Well, they both go into 5. So I'm going to write my LCD of 5 over here. So we just have to multiply by 1/1. There's nothing to do there. 3x times 1 is 3x, right? Here, to get a 5 in the denominator, we have to multiply by 5/5. Now 5/5 is really just 1, so we're not really changing the value of this fraction. We're just changing the form of what it looks like. 5x times 5 is 25x. And now we can add them together, 25x and 3x, that would be 28x/5. And that is our answer, right? Okay, so let's look at some down below. We have some more addition and subtraction problems. Again, I like to write them vertically. So I'm going to rewrite this 5 over 6x, 2 minus 4x over 8x. And we are adding, right? So let's see. We need to find a common denominator for 6x and 8x. Well, what do 6 and 8 both go into? If we start with the largest one, the 8, look at multiples of 8. 6 doesn't go into 8. 8 times 2 is 16. 6 doesn't go into 16. 8 times 3 is 24. Well, 6 does go into 24, right? So we can have a 24. And they both have a factor of x. So 24x. And then I can see what I can multiply both fractions by. Let's see. 6 times 4 is 24, right? So 6x times 4 would be 24x. So we multiply by 4 over 4. Here we get 20. Here we have to multiply by 3 over 3, right? Now, again, a fraction bar is a grouping symbol, so that 3 gets multiplied by, distributed through both parts of this. So we have a 3 times 2, which is 6, and 3 times negative 4x, which is minus 12x. Now we can combine these, right? 20 plus 6 is 26. And then plus a negative 12x, we just have minus 12x. And that's over 24x. Alright, so let's think. Is there anything else we can do? Is that in lowest terms? That's one thing to always check, right? Is it in lowest terms? Like if we were going back to this one, there's no common factors here, right? No common factors here. We can't factor anything. Same thing here. Down here, though, if you notice, once we get down to here, we could factor a 2 out of both the top and the bottom, right? And so maybe I'll do that here. So factor a 2 out, we get 13 minus 6x. If we factor a 2 out of this, we get 2 times 12x. And the 2's will cancel. And so we have an answer now that's in lowest terms. 13 minus 6x over 12x. Some people may be tempted to cancel the 6x and the 12x, but again, we can't do that. 13 and 6x are held together by subtraction, not multiplication. So this would be our answer in lowest terms. All right, we'll look at the next one. We have 3 fractions. Well, this was not a fraction, but we could put it over 1, right? So I'm going to write this vertically, 10 over 1. And so minus y over 7. So I'm just going to do this a step at a time. I'm just going to take care of this one first, right? Order of operations, addition and subtraction, you do left to right, so we can take care of these 2 first. So common denominator is 7. This one's already a 7, right? Subtracting, and this we can multiply by 7 over 7, which gives us 70 over 7. So then we'd have 70 minus y over 7. Okay, so we've combined these 2 together, right, with the subtraction. And now we want to add our result to this guy. So I'm going to write this vertically as well. So 70 minus y over 7. And we're adding 3 over y plus 2. Alright. So we need a common denominator. Well, 7 and y plus 2, they don't have any common factors, so your LCD is just the product of the 2. And so for our LCD, we're going to have a 7 times y plus 2. Alright. So for this guy, we need a y plus 2. I'm going to put that in parentheses. Y plus 2 over y plus 2. And for this one, we need a 7 over 7. Now you could FOIL this out, but I don't really think we, well, we might want to do that in this case. So let's see, 3 times 7 is 21, right? 21. Up here, let's go ahead and use the FOIL method. So 70 times y is 70y. First times first. 70 outer times outer. 70 times 2 is 140. Inner times inner is a negative y squared, right? Minus y squared. And then last times last is a negative 2y. Kind of squeeze that in there. Okay, so now we're going to combine all this together, right? It's a plus sign, so let's see. So we can, let's start with a negative y squared. I'm going to put that in front. So negative y squared. So that's taken care of. And then the y terms. We have a 70y minus 2y, so that's plus 68y. Okay, so I combine those two. And then we have 140 plus 21 is plus 161. And this is all over 7 times y plus 2. All right, so we have successfully added, and we could see if this could be factored, but I don't think it can. And even if it could, we can't take out a factor of 7, or I don't think we can take out a factor of y plus 2 because this is an odd number, right? So this is reduced completely, and we are in good shape. All right, let's look at the next one. Here we're subtracting. I'm going to write it vertically, 6x squared over 2x plus 5. We're subtracting 4x minus 3 over 3x squared. Okay, your common denominator. Since these two denominators don't have any factors in common, your LCD is just the product of the two. So your LCD is going to be 3x squared times 2x plus 5. Alright, so in order to get that denominator, we need to multiply this by 3x squared on both top and bottom. So if we take 3x squared times 6x squared, that's 18x to the 4th. Here we need to multiply both top and bottom by 2x plus 5, right? And again, this is a grouping symbol, fraction bar is, so really we need to FOIL this on the top. 4x times 2x is 8x squared. I'm going to do the middle term, kind of combine things here. So we have 4x times 5 is 20x, and 2x times negative 3 is minus 6x, right? So 20 minus 6 is 14x. So our middle term is a 14x. And then negative 3 times 5 is a minus 15, right? Alright, so where are we at here then? So this is all subtracted, right? So this minus sign gets applied to every one of these terms. So let's start compiling our answer. We have 18x to the 4th. We're subtracting each one of these, and if it helps you, put that in parentheses, right? So minus 8x squared. And then minus 14x. And then minus a negative 15, which is plus 15, right? And that's all over 3x squared times 2x plus 5. And I don't think there's anything else we can do at this point. This is 4 terms. You could say let's try to factor by grouping, but it's not going to help us any. It's not factorable really. So this would be our answer. Okay. So let's look at another one of these. Here we're adding. I have 7x. Well, I'm going to go ahead and factor the denominators before we go any further. So let's factor the denominators. They're both trinomials that are fairly easy to factor into 2 binomials. So let's see, we have x times x to get the x squared. 2 factors of negative 8 that add up to negative 2. We need a negative 4 and a positive 2 would work. 2 factors of negative 4 that add up to negative 3. So what do we need there? We need a factor of negative 4 and positive 1, right? So your LCD, let's think about this. We're going to write this down. So we have 7x over x plus 2 times x minus 4. and 4 over x minus 4 times x plus 1. And we're adding those together. When I go to find my LCD, it needs to contain one of each factor, but we don't need, if one shows up in both places, we don't need to list it twice. So we need a factor of x plus 2. We need a factor of x minus 4. And the only thing we have not listed is this factor of x plus 1. We already have a factor of x minus 4, so we don't need it again. So we have that same LCD down here. So what do we need to multiply this by in order to, this denominator by, in order to get this over here? Well, the only thing missing is the x plus 1, right? So we need to multiply this by x plus 1 over x plus 1. So if we multiply 7x, we could distribute it through here. We get a 7x squared plus 7x. We need to multiply this denominator by x plus 2. That's the only thing missing, so times x plus 2 over x plus 2. So distribute the 4, we get a 4x plus 8, right? And now we can combine these together. We have our 7x squared. It's addition, so 7x plus 4x is 11x, right? Plus 11x. And then we have plus 8. And then we have our LCD on the bottom, our x plus 2 times x minus 4 times x plus 1. And that would be our answer. Right, so we did several examples of adding and subtracting rational expressions on this page, and I think we'll do some more on the next page.